Myself, Dr. R Keshavulu, Associate Professor, Department of Physics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss about the different types of oxide glass systems. Previous class I discussed the same topic only, but further I continue to same topic, different types of oxide glasses part 2. So last and previous session we discussed on different types of oxide glass systems. So last class we discussed about the borate glasses, that means B2O3 glasses. Other one is phosphate based glasses, P2O5 based glass systems. These are we discussed in last section. So now we are going to discuss about today outline of the topic is oxide based glass systems, borate glasses, that is based on the B2O3. The second one is phosphate based glasses. These are discussed in the last session. Now this section we are going to discuss about the silicate based glasses, that is silicon dioxide SiO2 based glass systems, and tellurate based glass system TeO2, that means tellurium oxide doped glass systems. Next other one is germanate glasses, that is germanium oxide doped glass systems. These are the we are going to discuss about the three types of different glass systems, that is silicate based glass system, tellurate based glass system, and other one is germanate based glass systems. So first is oxide based glass systems. In first we are going to discuss about the silicate based glass system. That is silica is nothing but sand. That is we are taking from the sand only silica. We are first into the sand, we are making a silicon dioxide powder. That is silica glass provides the reference model for most oxide glasses and the periodic association of silicon tetrahedral units, that is SiO4. Tetrahedral units gives a simple and a clear picture for the vitreous network. A silica glass shows a superior refractory nature, thermal shock resistance, optical transparency in both the UV region and visible region, and high chemical durability. These are the important parameters for the silicate based glass systems. Due to these properties, silica glasses has been widely used in the semiconductor industry as a crucible for the formation of silicon. Mainly using for the formation of silicon, they are using the industry applications. A mask blank for photolithography also they are using the silicon dioxide based glass systems, as well as various optical elements in optical and optoelectron devices applications also they are using the silicate based glass system. That is one of the prominent glass system for the industry applications, that is the silicon dioxide. Next, coming to the drawback of this glass is an industrial material. If any is high cost due to its very high viscosity, which requires a temperature, that is melting temperature above 2000 degrees centigrade for continuous mass production if the melt quenching technique is applied. This is one of the important technique to grow or synthesis the glass material we are using for the melt quenching technique. These are the one of the important technique to grow the glass systems. In the case of silicate based glass systems, the melting temperature it requires more than 200 degrees centigrade. 2000 degrees centigrade. Commercially, silicate glasses is supplied in the form of tubing, plate or rod and reformed by the heating to a temperature around 1800 degrees centigrade into the desired shape depending on the applications. These are the important applications. We are using the melting temperature of silicate. Commercial silica glasses we are using melting temperature is around 1800 degrees centigrade. The reduction of mass melting temperature from that of silica about 2000 degrees centigrade to a level of 1500 degrees centigrade that is more suitable to mass production is made by adding various modifier oxides to the glass composition. So whenever we are decrease the melting temperature in silicate based glasses, we can add some modifiers, different kind of modifiers we can add into the glass composition. We have to reduce the melting temperature from 2000 degrees centigrade to the 1500 degrees centigrade. That is from 2000 degrees centigrade to 1500 degrees centigrade. Whenever adding the glass modifiers, that means lithium oxide, barium oxide, calcium oxide, this kind of modifiers we are adding into the glass composition, we can reduce the melting temperature from 2000 degrees centigrade to 1500 degrees centigrade. The addition of modifier oxides to silica leads to the breaking of strong silicon oxides as SiO silicon bonds. That means we are whenever adding the glass modifies into the glass former. That is glass former here, silicon dioxide, SiO2. That means that bonding nature, that non-bridging oxygen bonding nature will be break, because whenever breaking the non-bridging oxygens, we can reduce that melting temperature from 2000 degrees centigrade to 1500 degrees centigrade. This is one of the important parameter for the silicate-based glass systems, and reduce the melt viscosity. Next, coming to the representative of multi-component silicate glass, firstly developed by this concept is soda lime silicate, which is the most popular and makes up more than 90% of the commercial glasses, the typical composition of the glass. That is, this is main soda lime silicate glasses. Soda lime silicate, this is commercially important silicate based glasses. That is soda lime silicate glasses. That glass composition is silicon dioxide, that is glass former. We can use that percentage, how much means 70 to 74 weight percentage of silicon dioxide you can take. Next is 12 to 16% of sodium dioxide, Na2 oxide, and 8 to 13% of calcium oxide, and magnesium oxide is 1 to 4%, and 0.5 to 2.5% of aluminum oxide. These are the soda lime silicate based glass composition system. That is the 70 to 74% of silicon dioxide, and 12 to 16% of sodium dioxide, and 8 to 13% of calcium dioxide, and 1 to 4% of magnesium oxide, and 0.5 to 2.5% of aluminum oxide. These are the glass composition of soda lime silicate glass. This is one of the important commercial glass system in the silicate based glass systems. The role of sodium oxide is obviously to yield non-bridging oxygens and hence to reduce the melt viscosity. That is the melt viscosity, it should be reduce the melt viscosity whenever adding the sodium dioxide. Na2 adding into the glass composition, we can reduce the melting viscosity. The addition of calcium oxide and magnesium oxide is intended to improve the chemical durability of the glass, which is degraded by the introduction of mobile sodium ions. Whenever adding the calcium dioxide or magnesium oxide is one of the glass modifier to improve the chemical durability in the glass composition. That purpose we are adding the calcium oxide and magnesium oxide in the soda lime silicate glasses. The role of aluminum oxide, which is effectively lower the liquid's temperature of the system, is to improve the thermal stability and to hinder denitrification, as well as to improve the chemical durability. This is one of the important property for the aluminum oxide. Whenever adding the aluminum trioxide, that is Al2O3 with the glass former system, we can reduce the thermal stability at the same time to improve the chemical durability. These are the one of the important property in the soda lime silicate glasses. The biggest advantage of soda lime silicate glasses over others is the low cost of raw material and good workability, which is essential for the fabrication of the products with a variety of shapes. So different kind of shapes we can prepare the synthesize the soda lime silicate glasses. This is one of the important good advantage for the soda lime silicate glasses, because low cost at the same time workability will be very high, which is the essential for the fabrication of the products with a variety of shapes. We can prepare soda lime silicate glasses in circle type, square shape, rectangle shape, rod type, plate type. This kind of glasses we can prepare the soda lime silicate glasses in the case of silicate based glass systems. Next, coming to the silicate dioxide structure. So below figure shows the structure of glassy silica in two dimensions. There is a no long range order is present because glasses having the short range order, crystal having the long range order, because in this is a pure glass system. That is why there is no long range order is present, because it's having the short range order of the structure silicate glass system. However, there is local ordering with respect to the tetrahedral arrangement to oxygen O atoms around the silicon Si atoms is a very important role in the silicate glass systems. Fluoride ions have been observed to lower melting temperature. Whenever adding the silicate glasses into the fluoride content, it will reduce the melting temperature, lower the melting temperature, and also it contribute the eliminate of OH groups. That means water content, the OH groups, it will be reduced, decrease the refractive index, and provide fluoride ion conductivity in silica based glass systems. So whenever you add in the fluoride ions into the silicate based glass system, it reduce the melting temperature as well as to eliminate the hydroxyl content, OH group content we can eliminate in the glass system. That is the important thing in the silicate based glass systems. From a structural point of view, network connectivity decreases as fluoride anions can be considered mainly as non-bridging oxygens. That is a very important thing. However, it may also lead to silicon loss through formation of gaseous silicon fluoride content. The gaseous silicon fluoride content, it can be reduced in the silicon glass system. This is the structure of the silicon dioxide glass system. These are the silicons is surrounded by the different oxygens. So this is the glass system, in the silicate glass system structure of the silicate based glass system. Now coming to the replacement of sodium oxide and or calcium oxide by other oxides such as potassium oxide KTO, potassium oxide, lead oxide PbO, strontium oxide SRO, and borate B2O3, boron trioxides. These are leads to the modification of the property of glass. Some properties of commercial silicate glasses detailed in table 1.2. So this table shows the different chemical composition for the silicate based glass system. First, you see this is the glass composition for the silicate based glass system. This is glass former silicon dioxide, next aluminum oxide Al2O3, next borate boron trioxide B2O3, calcium oxide, magnesium oxide, sodium oxide, potassium oxide, lead oxide, and other content. So this complete weight percent of different kind of composition take into the silicate based glass. First one is the sheet glass by floating method. They are preparing the glass system. Next one is container glass system. Next crystal glass system. Next optical glass SF. This is commercial based glass system SF6. Next optical glass BK7. This is the one of the commercial based glass system of silicate glass. Next laboratory wear glass systems. This is electric glass stem. This is one of the kind of silicate based glass system. Next TV panel glass also they are preparing by using this glass composition. Next TV funnel and TV neck. These are the different kind of glass systems while using the preparation of the silicate based glass. See here, see silicon dioxide glass formers is different glass formation weight percentage. In this case of sheet glass by float method, they are using 72.6 weight percent of silicon dioxide. In the case of TV funnel, they are using 51% of silicon dioxide. This remaining other glass modifiers and other low concentration of the different kind of other elements also they are using in the preparation of silicate based glass systems. Since the one of the here they given two commercial important glass system, that is optical glass SF6 and optical glass BK7. These are the important glass system in the commercially they are preparing for the silicate based glass system. So this table shows the different kind of chemical composition in industrially glass manufactured by melt quenching technique only. They prepared this glass system by using the melt quenching technique. Next coming to the telluride based glass system. So telluride based glass materials is present greater potential applications for solar energy technology and laser devices. It is because this material present very efficient optical and physical properties. So these are the telluride based glass system is a potential application for the solar energy technology and also laser device applications also using the very high portion of the telluride based glass systems. It is mainly very efficient for the optical and physical properties. So telluride glass systems doped with lead tellurium, cadmium tellurium, cadmium tellurium sulfide and rare earth materials are considerable due to its practical importance in technological applications such as integrated optics, optoelectronics, lasers, broadband optical amplifiers, and solar energy conversion. These are the different kind of applications while using the telluride based glass systems, because it's having the low photon energy, at the same time melting temperature also very low, At the same time, it will reduce the lot of applications in the telluride-based glass systems. That are the one of the important technology we can use the telluride-based glass system. The challenges in the solar energy technology research are to increases the conversion efficiency compared with that of silicon solar cells and consequently to make them more cost effective for commercial applications. So for the commercial applications, they are using the effective challenges in the solar energy technology research also they are using the in the case of cost effective for commercial applications they are using the telluride based glass system, that is tellurium oxide. So telluride glasses doped with rare earth ions, so telluride glasses doped with a different kind of rare earth ions were demonstrated as very broadband optical amplifiers and laser devices. So broadband optical amplifiers telecommunication purpose they are using the different kind of telluride based glass systems, and also they are using for laser device applications also they are using for the tellurium oxide based glass systems. These are the important properties in the telluride based glass system. Next, coming to the tellurium trioxide decomposes when heated to dull redness with the formation of the tellurium dioxide TeO2. TeO2 is the white crystalline solid which can be melted at 733 degrees centigrade without the gain or loss of oxygen. This is a very important thing here. Whenever melting temperature they are using for tellurium dioxide, that is TeO2. While using the melting pitching technique, they are using melting temperature is the 733 degrees centigrade at that time without gain or loss of the oxygen. That is one of the important thing for the telluride based glass systems. Next, melt of pure tellurium oxide do not solidify to form a glass, but glass formation has been shown with systems for more than 90 mole percent of tellurium oxide. That is, tellurium oxide is a rich area for the phase diagram, and no other glass former present in the tellurium based glass system. This is the one of the important thing for the tellurium based glass system. Since the earlier work of Berzelius in 18th century, 1834, very little was contributed to work on telluride compound until Lenhar and Wodanski in 1933 studied the chemistry of the so named the metallic tellurides and observed that sodium di and tetratelluride fuse below the red heat to form a clear glass. So these both scientists they studied the telluride based glass systems. They use the no named metallic tellurides and observed the sodium di and tetratelluride, that is T4 plus fuse below and red heat to form a clear glass systems. They are studied the initially there not much work is studied on the telluride based glass system in this in the year of 1834, but after 1913 they studied the in chemistry applications purpose their sodium di and tetratelluride based glass systems they studied more in the 18th century. Next, coming to the telluride glass systems. In 1952, Stanworth performed the first major systematic studies on telluride glasses on the basis of tellurium T4 that has an electronegativity in the range of other good glass forming oxides as shown in table 1.3 with some network formers for comparison. This is known as Stanworth's electronegativity criterion. This table shows the electron negativities of good glass forming oxides and network modifiers. So while using the calculation of the electron negativities, we can prepare the good glass forming oxides while network formers, otherwise network modifiers. So here in this table shows the different kind of elements in the glass formers and also network formers and also network modifiers. So first we discuss about the network formers. Tellurium poly electronegativity value is the 2.10. In the case of boron, that poly electronegativity value is 2.04. In the case of silicon, it's having the 1.90. In the case of phosphorus P in phosphate based glass systems, that value is 2.19. If germanium, if you are taking 2.01 its value. If you arsenic, if you take As 2.18. If you take tin Sb, that is 2.05. These are the different kind of glass network formers based on the electronegativity. We can prepare the good glass forming oxides while using the Pauli electronegativity values. In the case of glass network modifiers, lithium, sodium, potassium, lithium having the 0.98 electronegativity value. In the case of sodium is having the 0.93. In the case of potassium, K having the 0.82. These are the electronegativity values to prepare the good telluride based glass systems. That is this table shows the electronegativity of the good glass forming oxides and network modifiers. Next, coming to the structure of the tellurium oxide glasses. The structure of telluride glasses, tellurium oxide has a shape of tetragonal. Is having the shape of tetragonal. Earlier works suggested the network in telluride glasses consisted of strongly deformed, that is tellurium oxide TeO6 units, analogous in structure to rhombic beta tellurium oxide, where Te44 is coordinated to 4 oxygens, is surrounded by the 4 oxygen, that is Te4 plus. This figure shows the crystal structure of the tellurium oxide. This figure shows the crystal structure of the tellurium dioxide, TeO2 plus. So, structure of tellurium oxide, alpha tellurium oxide, A is the alpha tellurium oxide, this one, B is the beta tellurium oxide. This arrows mainly represents the tellurium 5s electrons ion in the pair systems. These are the crystal structure of the tellurium dioxide, TeO2. This is the diagram for the telluride based glass system crystal structure. Next, coming to the last one is the germinate or germanium based glass systems. So, germinate glasses, germanium oxide, dioxide, GeO2 containing glasses have become important material in the telecommunication and optics industries. So, these are the germanium oxide, GeO2 based glass systems. They are using much applications in the telecommunications and also optics industry applications. They are using the germanium based glass systems. The attempts to improve the transmission loss in optical fibers brought about the use of germanium dioxide to make better optical fibers. Instead of silicate glasses and borate glasses, the germanium based glass systems, we can use the prepare the optical fibers. Optical fibers, they use the to transmit the data in the long distance. We can use the optical fibers. That applications they are using the instead of silicate and borate glasses, they are using germanium based glass system. This is one of the important applications for the germanium based glass system. They are using for the optical fiber applications because we can transfer the data or information from long distance, even though one country to other country also using the optical fibers. In the case of germanium based glass system, they are prepared for the optical fibers. That is one of the important advantage in the germanium based glass systems. So coming to the germanium dioxide, single component glass consists of a random 3-dimensional network of germanium, oxygen, germanium bonds similarly to silica based glass. This structure, germanium oxide, GeO germanium, that is germanium, oxygen, germanium, silicon, oxygen, silicon. This both similar to the silica based glass system and germanium based glass system. Both are that bonding structure will be similar, network structure will be similar. Next, coming to the germanium oxide glass and multi-component germanate glasses show fair chemical durability but are used practically as although they have similar properties those of silicate glasses, the raw materials is far more expensive. So these glasses, if compared to silicate glasses and germanium glasses, these are the very cheap compared to the silicate based glasses. That is why we are using for the germanium based glass systems. Next, the only very special applications. So the only very special application developed for glass of this system is infrared transmitting glass. So in germanium based glass system, it optical spectroscopy they are using for the up to infrared transmitting based glass system. The higher infrared transmission of germanate glass than silicate is attracting people to use it as the potential material for ultra low loss optical fibers. They can use for the germanium based glass system the potential material for the ultra low loss optical fiber system also they using for the germanium based glass systems. So this is also one of the advanced application for the germanium-based glass systems. Next, germinate glasses is oxyfoil glasses were first considered because they show less light scattering than pure germanium oxide glass. Glass forming oxide has a higher linear coefficient of thermal expansion. That value is 75 into 10 power of minus 7 per degree centigrade. Then either glass forming silica or boron anhydride high coefficient of thermal expansion has a great importance in industrial applications where high vacuum seals with brass or copper are required. So in this application, the very high vacuum seal of brass or copper are required because it's having the thermal expansion coefficient will be very high. Now, then glasses in the ternary systems possess a high linear coefficient of thermal expansion. That value is 118 to 116 to 10 power of minus 7 degrees centigrade. These glasses weld to metal, copper or brass at relatively low temperature. They are using this can use when the temperature is very low temperature, that is 530 degrees centigrade to 640 degrees centigrade. Low temperature we can use to prepare this kind of glass systems. Next, multi-component germinate glass composition can produce glasses that possess a high refractive index gradient. So, germanium-based glass systems produce the high refractive index gradient, making possible the creation of elements that are able to focus optical beams in other industrial glasses. In other industrial glasses, because it's having the high refractive index gradient. That is why they are using to optical beam focusing purpose. They are using for the germanium-based glass systems. Next, compared to silicate and borate systems, the germinate systems higher refractive indices, that value is 1.80 or more than that, can be obtained for considerably smaller concentration of the heavy elements oxides. That is, heavy elements oxide is here mentioned here. Lead oxide PbO, next bismuth oxide B2O3, next niobium oxide NB2O5, next tantalum oxide is Ta2O5, next titanium oxide TiO2. These are the heavy metal elements. In the periodic table, see the heavy metal oxides are these are lead, bismuth, niobium, tantalum, titanium. These are whenever added into the germinate based glass system, we can increase the refractive index of the glass system. So that purpose they are adding this heavy metal oxides into the germinate based glass systems to improve the high refractive index. For refractive indices in the range of ND value 1.60 to 1.65, oxides are not even required. Glass forming germanium oxide has unusually high Brewster coefficient, B value equal to 7.5, which is approximately 2 to 5 times higher than that found in the other industrial glasses. In other industries, if we compare, this value will be very high. If glass forming germanium dioxide is optically transparent, this is a very important thing. So, glass forming of germanium dioxide is optically transparent over the wide spectral range, that is from 280 to 5000 nanometer. So, in this spectral range, we can optically transparency will be more in the glass forming of the germanium dioxide. There is a lot of applications they are using for the germanium based glass systems because its transparency optically highly transparent, since from 280 nanometer to 5000 nanometers, still ultraviolet to visible, near infrared, far infrared, mid infrared, all regions it will be shows the optically highly transparency. So that way they are using for different applications germanium oxide glass systems. So quality and spectral luminescence of germanium glasses along with the generation characteristics make them effective material for the construction of lasers. So having this important property optically transparent in over the wide spectral range, that is from 280 nanometer to 5000 nanometer. In the luminescence also, spectral luminescence also very high. That is why they are using for different applications of the construction of laser devices. They are using the germanium based glass systems. Next, coming to the structure of germanium dioxide. So, structure of germanium oxide glasses, the two predominant polymorphs of germanium oxide are hexagonal and tetragonal. These are the structure of the germanium oxide. Hexagonal germanium oxide has the same structure as beta quartz with germanium having coordination number 4. Tetragonal germanium oxide, the mineral argument, this is looks like a rutile-like structure. It shows the rutile-like structure for the germanium-based glass systems. In this mortified germanium has to coordination number is 6. An amorphous glassy system from germanium oxide is similar to the fused silica. So if you are this rutile-like structure, the same structure we can see in the silica base, that is fused silica glass system also looks like similar pattern, because that structure pattern should be similar to the germanium based glass system, and also fused silica also looks like same thing, that is rutile like structure. These are the structure of the germanium based glass system. Next, these are the references we observed in this presentation. So these are the from first to 12 citations. These are the important while preparing the borate glass systems, silicate based systems, germanium based glass systems, and telluride based systems. These are the important citations for the different types of oxide glass systems. Thank you. Next section to be continued in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.